In question 1, we are going to find the value of I, which is the definite integral from 0 to pi over 4 of cos of 2x with respect to x. So please pause the video and try this. Okay, let's have a look at the solution. So in this definite integral, we're integrating an integrand of cos 2x. And if you remember from earlier in the integration part of the course, this is a standard result. And just to remind you, I'm going to write down the derivative of a function f dash x, like so. And if this derivative is cos of ax, where a is a constant, then if I integrate, I'm just going to use an arrow and a big capital I to denote integration there. I'm going to get an antiderivative of f of x, and the cos ax integrates to 1 over a sine of ax. And I'm writing this down because this is going to be useful later on in the preparation task. This means that I can replace, or I can integrate cos 2x and replace the a with 2, and I've got my antiderivative. Let's do it. So I is going to be equal to, big square brackets now because integration is done, 1 over 2 sine of 2x. If you have time, of course, quickly differentiate this in your head to make sure that you do in fact get cos 2x. And this is evaluated between pi over 4 and 0. Standard notation now. I'm going to remove the square brackets and introduce curved brackets and make my upper limit and lower limit substitutions. So I'm going to have 1/2 of sine of 2 lots of pi over 4. Now, 2 times pi over 4 is obviously going to be 2 pi over 4, which is pi over 2. There it is. Okay, so that's my upper limit done. And then I'm going to subtract my lower limit, which is 1/2 sine of, now 2 lots of 0 is just going to give us 0. So let's get that in there. Close the brackets. Let's complete the task. So we have 1/2 sine of pi over 2. Sine of pi over 2 is 1. So I'm going to have 1/2 for the upper limit evaluated, and sine of 0 is obviously going to be 0. I'll just, for completeness, I'll put that in. So the final answer is going to be 1/2. And now we have to integrate I1, a definite integral, and there is a hint to use a double angle identity. So please pause the video and try it. Okay, and let's have a look at the solution. Next up, we have a slightly more challenging question. We have cos squared in our integrand. This is called I1, and we're told as a piece of advice in the question to use a double angle identity. So you probably were racking your brains which one to use. I'm going to write down the one which I feel is the most useful at the moment anyway. So if I write down cos of 2x is identical to 2 cos squared x subtract 1. I say this is the most useful because the alternative would have been cos squared subtract sine squared, but then you would have to have dealt with the sine squared, and we're not going to do that in this question. So here I can rearrange this by adding 1 and dividing by 2 to make cos squared x the subject. So let's do that now. So cos of 2x plus 1 is absolutely identical to 2 cos squared x. Great. And dividing by 2, so 1/2 of cos 2x plus 1/2, it's dividing both those terms by 2, is identical to cos squared x. Great. So now we have something we can use to substitute into our integrand. Okay, this is very straightforward to integrate. So I'm going to replace the cos squared x there. So that's the next step. I'm just going to partition the board just so I have a bit more room. Like that. So my I1 is now going to be equal to the integral from 0 to pi over 4, and why not just make it really, really clear that I've done a substitution here. So this is going to be 1/2 of cos 2x plus 1/2, like that, and that's integrated with respect to x. So we'll put some brackets around that. Dx. Great. Now it may be your preference to factor out the 1/2, okay, to make the integrand a little bit more straightforward. Why don't we do that? So this is going to equal 1/2 of the integral from 0 to pi over 4, open a bracket again, of cos 2x plus 1 dx, and closing the bracket, of course. Great stuff. Now we can carry out the integration. So this is going to be equal to, open a big square bracket now, and before I forget, what I should have done is put the half at the front. My apologies. Let's do that. So 1/2 at the front because I factored it out, so I need to have it multiplying my integrated expression. So as we saw earlier, we've already integrated cos 2x. That was useful, wasn't it? So remember, this was 1/2 sine of 2x. Like that. And integrating 1 will just give us x if we're integrating with respect to x. And close the square brackets. Okay, now remember, this is integrated now, but we have limits, so we put pi over 4 as my upper limit and 0 as my lower limit. For the next step, I'm just going to drag this all the way across here so we have a bit more space, and we're going to sub in our upper and lower limits. So first of all, let's remind ourselves that we're multiplying everything by 1/2 here. That's really important, so that's going to go first. And I'm going to open a big square bracket, and I'm going to keep this because I'm multiplying the entire thing by 1/2 and I don't want to forget that. So I'm going to use the curved brackets inside the square bracket. So first up, we are going to sub in pi over 4, and I'm going to use green for that one. So this is going to be 1/2 of the sine of 2 lots of pi over 4. Now if you multiply pi over 4 by 2, we saw this in the previous question, you're going to get pi over 2. There we have it. And then this time we're adding pi over 2. Beg your pardon, pi over 4. There we go. So that's the upper limit substituted in. We'll evaluate that in a moment. Let's put the lower limit in as well. So we're subtracting, so this is going to be subtract, open up the curved bracket again, and we're going to have this time 1/2 sine of 2 lots of 0, which is just going to be 0. So 1/2 sine of 0, like that, and plus 0. Okay, and then we'll close the curved bracket and the square bracket now. So that's the lower limit done, and also we have finished substituting everything in. Now I'm just conscious of space here, so let's just talk. Let's just argue away some of this content. In the lower limit, I've got 1/2 multiplying sine of 0. Sine of 0 is obviously 0 plus 0. This term is just going to become 0. No, nothing to worry about there. Over here, we have sine of pi over 2. Remember, sine pi over 2 is 1. Multiplied by 1/2 will be 1/2, plus the pi over 4. And then all of this will be multiplied by pi over 2. So we can write down the final value now for this. 1/4 plus pi over 8, and we're finished. Following on from question 2, we're now going to look at I2, which is a definite integral of sine squared x with respect to x. Please pause the video and try the question. Okay, let's have a look at the solution. Next up, we're integrating sine squared x, and it uses the word now, so there's an implication there that we're going to use a similar process. And the process is the double angle identity, and we're going to use the sine squared version of the cosine double angle identity. Let's write it down first of all. So cos 2x is identical to 1 subtract 2 sine squared x. Remember, these identities are not provided. You have to know them, or you can derive them from the compound angle identities, but that's another matter. And if we rearrange this identity, we then have something we can replace our sine squared in the integrand with. So let's add, no, let's not add, let's subtract 1 from both sides first of all. Or if you prefer, we can add 2 sine squared x to both sides, and we'll have nice positive terms to play with. In fact, I will do the latter. So 2 sine squared x is identical to 1 subtract cos 2x. So again, I've subtracted the cos 2x from both sides also. Now we can divide by 2. So sine squared x is identical to 1/2 subtract 1/2 of cos 2x. And now we have a nice expression we can replace sine squared with in the integrand. So here it is. So we're going to replace sine squared here with 1/2 subtract 1/2 cos 2x. Let's partition the board and let's do the substitution. So I2 is going to equal the integral from 0 to pi over 4. Open a bracket, and I'm going to replace the sine squared with what I've just derived. You'll have done this several times by now with all the integration you've done. Cos 2x. And let's just close that. Dx. Just fits on. If you want to, if you prefer, let's drag out the 1/2 to make the integrand a little bit more simple. So this is going to equal 1/2 of the integral from 0 to pi over 4 open a bracket, 1 subtract cos 2x. Close your bracket, and with respect to x. Let's perform the integration. Same idea as previously, we just have different signs and a different arrangement. But it is standard, so it's going to be 1/2. Open a big square bracket now because of the limits. And if we integrate 1, that's going to give us x. And the integral of cos 2x, as we've seen twice now, is 1/2 sine of 2x, and all evaluated between pi over 4 and 0. And at this point I'm going to move my working out over to this side so I've got some space. So this is going to equal, I'm going to put the half on the outside to remind me not to forget to multiply everything by half at the end, and we're going to substitute in our upper and lower limits. So x this time, well, x is pi over 4 in the first instance in the upper limit, so pi over 4 goes in first, subtracting 1/2 of sine of 2 lots of pi over 4, which, as we saw twice now, is pi over 2. Let's close that bracket. And that's the upper limit done. Let's look at the lower limit now, which is being subtracted from that. Subtract lower limit. And this time we're substituting 0 in everywhere. 0, subtract 1/2 of the sine of 2 lots of 0, which we know is just 0. I'm doing this for completeness, of course, but you can do it a little bit quicker. And close those brackets. Now let's close the big square brackets and let's evaluate this integral. So as we saw previously, sine of 0 is 0. This entire term will just become 0. And we have very, very similar to the previous question. Sine of pi over 2 is 1. So I have 1/4 minus, or subtract, 1/2 of 1, which is 1/2. And all of that will be multiplied by 1/2. My final value will be the following, and we'll leave it in terms of pi again. So it's going to be pi over 8 this time. So I'm multiplying pi over 4 by 1/2, and then this term becomes 1/2, so I'm going to be subtracting 1/4. And we're done. Now we're going to combine our 3 results from our definite integrals into an equation. So please pause the video and try it. Okay, let's have a look at the solution. Now we have the 3 values from the first 3 questions. So I is 1/2, I1 pi over 8 plus 1/4, and I2 pi over 8 subtract 1/4. What we're asked to do is to form some sort of equation linking these 3 solutions. Now I'll just leave the I for the moment. This is my target in a sense, because it looks like it's the simplest value. Is there a way I can form the value 1/2 from what I have here? If this is the case, I'm going to have to knock out the pi over 8, which we can see here, and the pi over 8 from I2 as well. This means a subtraction. Now, if I subtract I2, or beg your pardon, I1 from I2, the pi over 8s will will cancel, but I'm going to have negative 1/4 subtract 1/4, which is negative a half. I don't want that. So the only way I can do this is if I take I1 and then subtract I2 from I1. And you'll get there just with playing around with these numbers a little bit. So let's just confirm that. So if I take pi over 8 plus 1/4, like so, and I subtract, so I'm going to open a big bracket here, pi over 8 subtract 1/4, like so. This is going to equal pi over 8 plus 1/4 subtract pi over 8 add 1/4. And clearly the pi over 8 is going to cancel, and this is going to leave us with 1/2. So let's combine the numerical form of this with what we know to be I1 and I2. So this part here is I1, and this part here is I2, and this is I. So clearly by performing that substitution, we get the result we want. So we're going to get I is going to equal I1 subtract I2. I may have laboured that a little bit, but just playing around with the numbers, you'll get there eventually. And finally, a bit of revision on integration using substitution. So please pause the video and have a go. Okay, and let's have a look at the solution. Now we have an indefinite integral, and this is nice revision of the topic on using substitution to solve integration problems. The substitution we're given is 1 plus sine x, so I've written that down already, and we're integrating this expression here in our integrand with respect to x. It's procedural now, so once you have the substitution, it's a case of just following through with the steps. First step is, of course, to differentiate your substitution with respect to x. So we're going to get du by dx and the derivative of 1 is 0, and then sine x differentiates to cos x, as we all know by now. That's the first step. The next step is to make dx the subject of what you have just found. So just a case of rearranging now. So dx is going to equal du divided by cos x. And these are the ingredients that we're going to use. We're going to use this because we've just taken the time to do that. That's going to be useful, and the substitution itself is also going to be useful here. I'm going to partition this off, and then we're going to sub everything into the integrand. So the integral of cos x nothing to substitute there, really. We're not going to replace it with du by dx. We have u square rooted, so I'm going to write that as u to the power 1/2. Please don't forget that u is raised to the power 1/2. Very important, don't just put u in. And then dx is replaced by du over cos x. So at the moment we have two variables in our integrand which cannot be processed, but notice that the cos x and the cos x in the denominator will cancel, and this is exactly what we wanted. This was the purpose of the substitution. So we're going to be left with the integral of u to the power 1/2 du, like that. And it's standard year 1 integration now. So this is going to give us add 1 to the power and divide by the new power. We're going to have u to the power 3 over 2. That's adding 1 to the power. And then I divide by the 3 over 2 I've just found, plus the constant of integration. And let's move over here just so I have enough space. Simplify that. 1 over 3 over 2 is going to simplify to 2/3 of u to the power 3 over 2 plus c, like that. And then all I have to do now is replace the u with 1 plus sine x, which we were given at the beginning. So the final answer is simply 2/3 of 1 plus sine x to the power 3 over 2 plus c. There we go.